everyone to the second day. We have a very interesting session ahead.
Fantastic. I assume that you can see the slides now. Yes, you can see them. Okay, so I'm going to talk about the value of a peer. And in this paper, we basically introduce a new approach to peer effects and a new way to think about peer effects. This is joint work with Ingo Isphording, who is at IZA in Bonn. So I don't think I have to motivate this a lot, but let's briefly talk about why we should care about peer effects. So how peers affect individual outcomes is really one of the fundamental questions in social sciences. If you look at the literature, there's like hundreds of papers about peer effects, and all of these papers are motivated by the idea that we all think that the people around us are really important for our decisions and our performance. However, if you actually look at the papers out there, there's not really a lot of consensus in the literature. So first, people don't really agree on how to estimate peer effects. So sometimes people use linear means models, sometimes linear and share models, sometimes they look at different ways of heterogeneity, but also there's no agreement on the size of peer effects. So if you look at point estimates, there's huge heterogeneity. So sometimes peer effects are large, sometimes they're small, sometimes they are not significant, sometimes negative and sometimes positive. So basically these estimates are all over the place. And third, and I think this is an important point where also this paper comes in, is there's no agreement about which peer characteristics matter. So some people say, well, what is very important is the achievement of your peers. Others say, oh, race is very important, or the gender composition is very important. But essentially you can look at a lot of different characteristics and it's not really clear which ones of these matter. So to understand what we're doing in this paper, I'm first going to say a bit about the state of the art in the literature. So what do you typically do when you want to write a peer effects paper? You take a data set and you take a peer characteristic. You take achievement, gender, or race. What you then do is you aggregate this peer characteristic at some group level. So for example, at the classroom level, you would compute the share of female students or the average achievement of students. Let me illustrate you this with this example of gummy bears. So I have these gummy bears here, and what you would do, for example, you would compute the share of red gummy bears in the classroom. This would be this XJ bar, and you would test how test scores, for example, are affected by this peer characteristic. Oh, by the way, you should just interrupt me anytime if you have any questions on the way. So the state of the art really seems to be to testing if observable aggregated peer characteristics affect individual outcomes. So what are the shortcomings of this approach, potentially from our perspective? So the idea we have here is that it might be that there are unobserved peer characteristics that really affect performance, things that we cannot observe, right? And we think that just because peer effects are small or sometimes non-existent in different settings, that doesn't mean that there's a lack of peer effects in general, right? So there might be a lot of interaction and spillovers between students, and students might learn a lot from each other, but if these spillovers don't follow the lines of observable characteristics, we might not be able to capture them and explain them well with the existing models. So what do we do in this paper? In this paper, we introduce a new approach to quantify peer effects, and we call this the peer value added approach. So essentially, we model peer effects with value added models, and how you should think about this peer value added. Essentially, peer value added isolates the total contribution of one peer to the performance of other individuals. So value added models have been used a lot, for example, in the teacher literature, where people have estimated teacher value added. You can think about this similarly. If you're not familiar with value added models, you could also think about this as a peer fixed effect. So basically, a value for each individual peer, how much that person adds to performance. So for example, I could ask the question, pick one peer and ask, okay, what's the peer value added of Victor or of Barbara, and then isolate this in the data and say, if I meet that specific person, I'm going to perform this much better or worse. That's essentially the idea. Let me tell you about the key findings I'm going to show you today. So I'm going to show that peers matter and that there is significant variation between peers value added. So not all peers are equal, and they differ in the impact that they have on grades, follow-up grades, and variation. I'm going to look at a setting in higher education, at a university setting. And I'm going to show you, and that's perhaps most striking, that observable peer characteristics, things I see in the data, are poor predictors of peer value added. So we don't do a very good job in explaining spillovers by focusing on those observable characteristics that we have. I think that's important because it means that we might be missing out on a lot of spillovers that are happening, but that we can't identify with observable characteristics. And then I'm going to go on and validate these peer value added measures. And I'm going to show that peer value added is a valid predictor of spillovers among newly assigned peers. I think this is really important because past research had kind of difficulties to show that those measures that you establish, that they actually have predictive power for a situation where you have reassigned students to new peer groups. So I think that's important. Then we're going to go on and try to find out where these differences in peer value added actually come from. So we're going to look at malleability of peer value added. What I'm going to show you there is that my peer value added, so how much you can learn from me, increases after exposure to high value added peers. I think this is interesting because it suggests that the ability to create spillovers really depends also on past interactions. So when I met valuable peers, I create bigger spillovers. Finally, we still look at interaction effects with teachers. So while peers and teachers have been studied a lot separately in the literature, we look at whether peer effects here is captured by peer value added, whether that differs depending on whether you have a high quality teacher, a low quality teacher, medium quality teacher.
I'd like to ask a question.
Yes.
How do you reconcile the third and the fourth bullet point? Because the fourth bullet point seems to suggest that this peer value added is not invariant to changing peer composition. So it's not invariant to the counterfactual. So that means that when you do out of sample predictions, which are counterfactual predictions, if it is not invariant, if it varies, it cannot be a good predictor.
So we show that
it's captured in the sample.
Absolutely. I think this is a good point. So here, what we assume is that it's kind of invariant at the year level. So I'm saying, okay, within the first year, I assume it's constant, and then I look at what happens in the second and third year. So this malleability is in a way small. So we do find that your peer value added is a bit larger after exposure to high value added peers, but it doesn't completely change, right? So in principle, you also don't have to make this assumption that it doesn't change at all. It could be that it changes, and what we're going to identify is kind of the average effect that is not malleable. But I see your point that this is there.
So are you saying that the out of sample predictions are valid for a short time or before they start changing, or I don't understand.
Basically, the malleability makes it harder for us to come up with an out of sample prediction, right? Because if it's malleable and changes, then it should be harder to establish that we can explain spillovers in the next year. The fact that we still find something in this out of sample prediction suggests that it's not extremely malleable and that we can have kind of a permanent component, something like a latent factor that seems to be constant over time. But I agree that this malleability might contribute to the not super high point estimate in the validation exercise. Yeah. Related literature. There's a large related literature out there. Many of you also have contributed to research on this. I'm not going to go through this in detail. This paper is clearly related to the peer effects literature. There's many papers out there. I think the key difference here with this paper in comparison to the existing literature is really the idea to allow for peer effects and unobservable characteristics and to come up with this value-added approach. At the same time, this paper is also related to the teacher value-added literature. So there, many people have used similar models to identify the impact of teachers on students, and there we do borrow some of the methodology. So in particular, we borrow from Jacob and Lefke in 2008, but also from the two Chetty et al. Papers, some of the methodology. So at the end, I'm going to compare some of our estimates to those that we have seen in the literature on teachers. Let me tell you a bit about the data that we use to empirically identify peer value added. So the data we use comes from a higher education setting.
Sorry, I was thinking that in principle, this, I mean, you are like kind of motivating this as an individual may have unique value added or among affecting basically in the same way all their peers, right? But even within a classroom, it is not clear that this is going to be the case. First, because the interactions between different students may have different intensities, but also like something that may help some guys within the classroom could also be very damaging or like have no effect on other guys in the classroom. So how should we think about that?
Absolutely, that's a totally valid point, right? So it might be that there is a specific individual in class that is a great peer for some students and a horrible peer for other students, discouraging other students. What this is going to identify is the average contribution of a peer to the performance of others. So it might be true that I might have heterogeneous effects, but what I'm going to get out of this is the average contribution of an individual on others. I'm not going to be able to say how heterogeneous this impact is. It's just going to say on average, in expectation, if I put this person into that class, I'm going to observe these learning spillovers. We looked a little bit into match effects. We looked a little bit into heterogeneity. We do see some significant effects, but these are not particularly large. But I think it would definitely be interesting to look more into this. How much variance is there in this peer value added in itself? Yeah. You can, to answer your question directly, you can think about it as a reduced form effect, right? So it's just the average reduced form effect of a person being present in class.
Sorry to follow up, but if there are heterogeneous effects, again, you have problems in out-of-sample predictions because you take the average, it's a reduced form and it's the average at the current composition. Once you change that, the average has to change.
Well, that depends on how different the current peers are from the future peers, right? So given that it's the same institution and probably similar students, I'm not
That's
sure.
true, but together with what you said earlier about the malleability,
Yeah.
I think that puts in doubt how good this is at really doing out-of-sample predictions.
So let's say I have a very heterogeneous impact depending on who I meet. So let's say I impact some people very positively and other people very negatively. This should make it harder to come up with a valid out-of-sample prediction exercise, right? So if assuming one value for all interaction is like the perfect approximation of reality, then I should get like super nice, super clean out-of-sample predictions. If I have a very heterogeneous effect and if there's no explanatory power for new social interactions, I will not be able to validate peer value added in an out-of-sample prediction. So if the impact is super heterogeneous, or I'm just capturing noise, I shouldn't be able and should make it harder to identify these effects in the out-of-sample predictions. That's what I'm thinking about it. We do a little bit to address your point that you just mentioned on whether these effects are indeed just like additive or whether it's super heterogeneous. So there we looked at residuals depending on the peer fixed effect and the student fixed effect heterogeneity. And there we do not see like major differences in the residuals across different combinations of student and peer quality. So this is a bit like the AKM decomposition, and there we think it's not crazy to have this this assumption. The data we use comes from a Dutch business school, and one of the key features in this setting is that students spend a lot of time in teaching sections, tutorial groups of 10 to 15 students. And these are the peer groups that we're going to focus on in this paper. So what do students do in these groups? Here's some pictures of what this group interaction looks like. Students basically solve problems in self-study. So they solve some problems at home, they read some papers, then they come back together and then they discuss their findings with their peers in class. So these are the peer groups that we want to focus on. And the key feature that we're going to exploit is that at this institution, for every course students take, students are randomly assigned to a class, to a tutorial section. Right? So we have repeated and random assignment to sections, and this is what we're going to exploit for identification. You need to observe individuals repeatedly to extract how much one individual contributes to the performance of others.
Hello? Excuse me, Ulf, are you getting me?
Yes, I hear you.
Okay, these students are from UG or PG level or mix of these students? Your sample size.
So how many students we're looking at?
Yeah, how many? And it's a mix of UG, PG or something means like mix of these students?
So I think we're looking at about 5,000 different students, but we observe them in a large different number of classes. So in the first year, we observed them in 8 different courses, and in the second and third year, we again observed them about 8 courses per year. In total, I think we have something like 300,000 social interactions, where we model like student peer-to-peer interaction as one observation. Does that answer your question, or?
Okay, it's okay, yeah.
So, I mean,
thank you.
If you think about the institution, it's not a particular selective institution. I think it's a typical European business school, if something like that exists. But yeah, it's not a crazy diverse student body, but also not as selective as some institutions. Okay, so we're going to exploit the repeated random assignment for identification, and here are the 4 steps that we have to estimate p-value added. So the first step is to reshape the data to have a dyadic data set of one-on-one interactions. So in this new data set, each student peer match represents one observation. This is really essential to take out the contribution of an individual peer, because you basically want to have it in every social interaction and then see how much one peer contributes. The second step is to take out all variation that doesn't come from the random assignment. So what we do is we extract residuals from a regression of performance on fixed effects that account for the level of randomization. So the level of randomization in our settings is courses. Within every year, different courses. So we take out these fixed effects. If we want to, we can also control for students' past performance. We could also control for a number of student observables. In practice, this doesn't really matter for the size of peer value added that we find. Now that we have these residuals, which capture residual performance, what do we do with it? We basically take all residuals for those social interactions where a given peer is present and average these. So essentially all residuals from all social interactions with the same peer. Whenever one peer is present, we take that and take the average. Victor, you have a question?
Yeah, Ulf, can you explain how you account for the reflection effect here?
Yes.
Because the performance of every student, even its fixed effect, even across different peers, reflect some effect of the others. So
yeah. So the reflection problem basically occurs when you regress outcomes on outcomes. So when you have student performance on the left-hand side and on the right-hand side. So first, it's very important to note that these residuals do not contain my performance, right? So if you compute my peer value added, there's no residual that comes from my performance. That's the first answer. So at no stage we are regressing outcomes on outcomes or residuals on residuals. But you could still be concerned about kind of an indirect reflection problem. So why is that the case? Because in the setting, I'm included both as a student and as a peer. And I think maybe this is what Victor is referring to. So what we did as a robustness check, we said, we're going to create a new data set where I'm going to treat you either as a peer or as a student, thereby basically removing the possibility of having some indirect reflection problem. So we did that and find like very similar variation in peer value added, and we can also validate these estimates in the out of sample prediction exercise. Does that kind of answer your question, Victor?
I'm not sure I understand what you do, and maybe when I'll see the model and the results, it might be more clear. It's hard for me to see how you can isolate the peer value added when all is estimated contemporaneously at the same time. But let's wait with that.
Okay, good. I'm just going to continue, and then if it comes up again, we can discuss it. Finally, the last step.
Let me just ask one question. So
Yes.
Are you using only information from the past, given what you've said about the possibility that I'm influenced by my former peers? So are you only taking information from the way I've influenced other peers in the past?
No, so in the first step, we're just estimating peer value added in the first year in university. So we are not using anything from the past, also because we don't really know who your peers were in high school. When we look at this malleability, we look at later periods and how that corresponds to the earlier period. So in the first step, it's all based on first year performance, centrally graded exams, nothing, we don't account for any previous interaction in that stage. So just say, okay, these people come in and we look at how they affect each other. The last step, which is also what is commonly done in the teacher literature, is we have a Bayesian shrinkage procedure that's really important if you want to put these peer value added estimates on the right-hand side. And one explains spillovers later on. And what it does intuitively, it assigns smaller weights to peers who have a higher variance in PVA. So those people who are, in a way, less reliable, or which we are less sure what their spillover is. So now, intuitively, this also assigns lower weights to individuals who may have a more heterogeneous impact on their peers, which comes back to the point that Michaela was mentioning. Here's an illustration with gummy bears on what we do in the estimation of peer value added. Essentially, we look at all these dyadic one-on-one interactions. We look at all these cases where a green gummy bear is present. We take the residuals, we take the average residuals out of that. That's going to be the raw PVA. We shrink it towards the sample mean to arrive at the final peer value. This repeated observation of peers in different groups, so sometimes somebody's present and sometimes somebody's not present, that allows us to really get an estimate out of this. If I observe every student only once, I cannot estimate peer value. The result tells us how much students will be affected in expectation by the presence of a specific peer. This is what you get out of this. So this is the empirical distribution of peer value added. The distribution looks fairly normal and is mechanically centered around 0. Since all of this is constructed based on residuals, it's mean 0 by construction. How large is one standard deviation in peer value added? One standard deviation in peer value added is equal to 3.6% of a standard deviation in grades. So if I meet a peer that is one standard deviation better than the average, this is going to be the expected performance gain that I can get, right? So it's not gigantic, but remember, this is only the impact of one individual student, right? So now the next question that we have is, okay, this is fine. This is the distribution of peer value added at the peer level, but how important are all peers together, right? To find out how all my first year university peers shape performance, we come up with peer capital. So peer capital is inspired by the idea of social capital, and captures how valuable all of my peers are. So we basically come up with this distribution of peer capital representing the sum of my peers' value added. I basically take all the 60, 70 different peers I met in the first year, sum up their peer value added, and look at distribution, and I look at the quartiles of this distribution. So I can be unlucky and be in the bottom quartile of peer capital, or I could be lucky and be in the top quartile. And we then ask how big are performance differences depending on what type of peers I met in the first year to get an idea of the overall impact of all peers. Top versus bottom quartile of the distribution. So the result is shown here. So here I'm showing you these 4 bars for the different quartiles of peer capital. What you see is if I have peers from the top quartile compared to the bottom quartile in the first year, the overall effect is equal to 15% of a standard deviation in GPA measured at the end of the first year. So if we take all peers together that meet in the first year, we do see a substantial impact of peers. That's what comes out of this. Now, the big question that you now have is, okay, fine, you've showed me something for peer value added and that there's some variation in peers value added, but the key question is what makes a peer valuable, right? So why do some people have a high value added and why do other people not have a high value added? What we do to find out about this is we look at the correlation between observable student characteristics and peer value added. The key finding here is that observable characteristics are poor predictors of peer value added. In particular, when we look at achievement. So here I'm showing you a bin scatter on the relationship between students' past grade point average, a measure of achievement, and students' peer value added, how much they add to the performance of others. So 2 things come out of this. First, the coefficient is very small. So 1 standard deviation increase in peer GPA is related to only 0.0016% of standard deviation in peer value added. So it seems that better students are somewhat better peers, but the effect is very small. The effect is only marginally significant. So based on this, it seems that past achievement is not a great measure for how much I can learn from somebody. We also looked at a couple of other characteristics. So we looked at gender, we looked at nationality, we looked at age, we looked at essentially the observable characteristic that we have in the data and looked at whether they correlate with peer value added. Also here, we don't find anything. We only find that GPA is marginally significant, but we do not find that any of the other observable characteristics explain peer value added. Importantly, when we, let me see if I can show that here. When we look at the test for joint significance, we cannot reject that these student characteristics are insignificant in predicting peer value added. So observable characteristics don't seem to explain this. Okay, so observable characteristics don't explain this, but what is peer value added then really measuring? So, you know, is this at the end of the day all just noise? It's constructed based on residuals. Is there something systematic in there? What are we really capturing here? So what we do to find out about this is we test if peer value added is correlated over time. So does my peer value added today correlate with my peer value added tomorrow? We then test if peer value added is correlated across subjects. So if I'm a good peer today, does that also mean that I'm a good peer tomorrow? We then look at the validation exercise, predictive power for new social interactions. And this is, I think, really important because this is what you want when you like to make recommendations that this is a valid measure. It can actually explain spillovers among newly assigned peers. I think this is key. Then we go on to investigate the metability and interaction effect with teachers. Let me show you some results on this. So here on the top left, we look at the correlation in peer value added across different outcomes. So we look at peer value added in today's grades. And 15 minutes left, okay. Peer value added in grades and peer value added in future grades. So what we do see is that if I am somebody who raises my peers' performance today, part of this effect seems to be persistent and also still reflected in future grades at a time when no longer present. On the top right panel, we see, and that might be mechanical, that those peers who raise grades also seem to increase graduation probabilities. This is not super surprising, given that if I have higher grades, I'm probably more likely to graduate. On the bottom left, and I find this interesting, here we look at the correlation between student self-reported study hours and peer value added. So this is what we basically see down here. And there we do see that if you meet more valuable peers, you actually seem to report fewer study hours, right? So this suggests that peer effort and peer value added might be substitutes. So if I have valuable peers, maybe I can learn something from them and I have to work less hard. I have to invest fewer hours. Finally, on the bottom right, we look at peer value added in subjective peer quality and look at how that is correlated with peer value added in grades. So here we're making use of individual level student course evaluations, and we're looking at questions like interacting with my fellow students helped me to better understand the subject matters, my tutorial functioned well. So all of these are self-reported student perceptions of the learning environment. And what I find interesting here is that these students seem to notice when there's a valuable peer in their class. So these perceptions of the group atmosphere correlate with peer value added. So these students seem to notice when somebody's in the room who improves overall performance. Next, we look at the correlation in peer value added between mathematical courses and non-mathematical courses. So we basically ask if you're a good peer in mathy courses, are you also a good peer in non-mathy courses? Again, this is constructed based on separate samples, right? So these samples do not overlap, and we do find there is a significant correlation. It's 0.2, it's like far from 1, but this again suggests that there seems to be some latent component that captures the same trait, right? So that there's something in these students that makes them good peers in both types of courses. Now we're asking, is peer value added something like a trait? I think it's tricky with using the word trait, and we have to be very careful here, but I think here are some reasons. So first, we find significant variation across individuals. We do find that peer value added is correlated across outcomes and over time, and we do find that it's correlated over context, right? So I think these findings suggest that maybe we are actually looking at something that we could call an underlying trait. And students notice these valuable peers. So now the question is whether we can explain spillovers once we reassign peers. So how do we do this?
One question.
Yes.
I mean, do you find that these peer effects, these kind of that they work equally well, or how similar are they when you compare weak classes and strong classes? So, I mean, can you say something about that?
Right. So in a way, we are doing that when we're looking at these mathematical courses and non-mathematical courses. I mean, at the course level, there's probably some grading on a curve, but that shouldn't affect how much spillovers we're able to identify. So I think looking at this correlation between mathematical courses and non-mathematical courses, where we have different average grades, tells us something about that. And the fact that it is correlated, I think, suggests that in like easy and hard courses, you know, these spillovers seem to be created by somewhat similar students, the same students. So
yeah, but it's a slightly different question. I mean, it's not about the course; it's about the students. So you know, I mean, so you suppose you're a great peer for the bright guys, doesn't also make you a great peer for the less bright guys. It's a different question.
Yes. So we looked at that. So we basically looked at whether peer value added, these estimates are heterogeneous depending on the ability decile of a student. And there we did not find much heterogeneity. But perhaps this is not surprising because in a way, what we're identifying with peer value added is just the average effect that you have on other peers, not accounting for the ability of these other students. But what we could do is we could go like one step further and say, now we're going to estimate value added for interactions with academically weak students. Now we're going to estimate peer value added for interactions with strong students. So that could be done. Haven't seen that in the teacher literature, but it would be interesting to also look at these correlations to see if whether you're good at raising weak students, you're also good at raising strong students. Yeah, I think that's a good suggestion. What I'm showing you here is the result of the validation exercise. So here we're looking at whether peer value added based on a separate sample, first year courses, can explain grades in second and third year courses. And we do see that there is a significant and positive coefficient. This coefficient, however, is far from 1, and I think that's important highlighting. So if you look at the teacher literature, these kind of reliability measures, they're typically somewhere between 0.4 and 0.7, and here we do see an effect of 0.1. So on the one hand, this is good news because it means we're capturing something that is able to explain spillovers among newly assigned peers, but it also highlights that peer value added might not be that constant over time, or that there might be some underlying heterogeneous effects that we're not able to perfectly capture. I think it would be interesting to look at this in greater detail. Here's a bit of robustness. This is basically just showing that this out-of-sample validation exercise also works when we include student fixed effects in the construction of peer value added, or if we include student fixed effects in the validation of peer value added, taking out all individual level heterogeneity that is constant over time. So there, our validation exercise still works. A bit on the malleability of peer value added. So is peer value added a malleable trait? Do past social interactions affect how valuable we are as a peer today? Here, we do find that those students who had better peers in the first year have a higher peer value added as estimated based on second and third year interactions. Again, these measures on the X and Y axis are constructed independently. And we do see a fairly small but positive effect here. So peer value added doesn't seem to change in a crazy way after exposure to more valuable peers, but it seems to change a little bit. So if we increase peer capital by 1 standard deviation, we get 4.5% increase in peer value added in the second and third year. The final thing I want to show you is how peer value added interacts with teacher quality. So peer effects and teacher effects have been studied a lot in isolation, but there's very little evidence out there that looks at how these things actually interact with each other. And that's what we're doing here. So how did we do this? We estimated teacher value added in a separate sample, came up with the distribution of teacher value added, and grouped teachers into low, medium, and high quality teachers. We then looked at where do we see the largest peer spillovers based on our out-of-sample prediction exercise framework. So the key thing that comes out of this is that peers really matter when you have a bad teacher. So essentially, the effect is like most pronounced in those cases where you have a bottom 33% value added teacher. This shows or suggests that good peers are able to compensate for low teacher quality. So one way to interpret it is that if your teacher is really bad and can't explain things, but you have good peers, they might make up for this and help your learning. Finally, what I'm going to show you now is a comparison to teacher and principal value added estimates. So other studies have estimated the impact of teacher value added, principal value added, and I want to benchmark our point estimates to these estimates. So what you can see here at the bottom, you can see our point estimate that we have, which is equal to 3.6% of standard deviation. That's the variation that we observe across individual peers. If you compare this to the literature on school principals, for example, you see that this is substantially smaller. Also, if you compare this to the point estimates to the variation that we have in teacher value added, you see this is substantially smaller. It's not so simple to actually compare these estimates. It's a bit tricky, but if you do so, these results suggest that the variation between individuals' peers is smaller than the variation between individual teachers or individual principals. Right? So this doesn't mean that they're overall less important, but there seems to be just less variation. And it would be super interesting to estimate this in other settings where you maybe have more heterogeneous peers, which are not all students at a business school. Okay, I'm slowly running out of time, so let me ask what's the value added of this paper and present 5 key takeaways that I would like to give you. First, what I've shown you today is peer value added as the new approach to detect the social influence of an individual. I think it would be super exciting to also apply this approach in other settings. If you think about labor settings, it'd be very interesting to estimate the co-worker value added, like how many spillovers a specific worker, for example, creates for his co-workers. And I think it could also be applied in many other educational settings where you have repeated observation of students, for example, in different subjects. Second, I've shown you that observable student characteristics are poor predictors of spillovers among peers. So we are only capturing a small part of the spillovers going on if we focus on the typically observable characteristics. Again, we might be able to explain more if we had more characteristics, more observables, but in this setting, these don't do a good job in explaining spillovers. I've shown you a bit on the validity of this peer value added approach. We see it's correlated over time and context. And I've shown you that it predicts spillovers among newly assigned peers. There is some evidence on the malleability. On the one hand, I think this is super exciting because it shows that, this is not a fixed trait. You can potentially change it. Maybe you could come up with interventions that would make students better peers. But on the other hand, it also suggests that if it is indeed malleable, then this creates some problems for the other sample prediction exercise, and that might contribute why our point estimate there is not high. Finally, I've shown you on the last slides that good peers seem to compensate for low quality teachers. And I think this is interesting because if you think about this, this basically opens up the possibility of coming up with reassignment policies, right? So once you have these nonlinear interaction effects with teacher quality, you could in principle think about assigning good peers to low quality teachers, and you would get something like a free lunch. I think we have to be very careful with these type of recommendations, but if we take the point estimates at face value, that would be the recommendation.
Yeah, I would worry a bit about moral hazard here, not to mention fairness. But maybe we have time for a very quick question. One question.
Can I ask a question?
Go ahead, Michaela.
Well, first, I just wanted to tell you about the interaction between teachers and peers. You may want to look at Todd and Wolpe in JP 2018, I think, or around then. They look exactly at that. And second, I'm still trying to wrap my head around what a peer value added is conceptually. And I'm gonna follow up a little bit with Victor's point about the reflection problem. So obviously the reflection problem poses econometric issues in identification in linear models. But conceptually, if you think of the micro foundation, the reflection problem is telling us, look, individuals may be playing a game with each other where they simultaneously choose outcomes. And so the equilibrium of that game depends on the composition of the peer group. So you can show econometrically that then when you run the linear means model, what you're estimating is a composite effect. It's the effect of the traits of your peers, but also this people best responding to each other. Now, and that's an issue that arises when you do the standard the standard estimation. Now, in your estimation, it's even more acute because you are stripping each individual of their peer group every time you identify something that is like peer specific. So if in the true data generating process, there was this best responding to each other, this reflection problem, I really cannot see what you're estimating here. On the other hand, if it didn't exist in the true data generating process, there wasn't, then I think it's a lot clearer what it is that you're identifying. It's some trait of individuals, how individuals affect others, and that is kind of independent of the group they're in. But the moment there are some endogenous peer effects, I really don't see conceptually what this peer effect that you're identifying is.
This is a great comment. I think the short answer to this is, I want you to think about this as a reduced form effect. So it's totally possible that we have very heterogeneous responses, students react very differently, but at the end of the day, I'm just getting the average effect of an individual peer. Now, the reflection problem, again, we're never regressing outcomes on outcomes. And we have an additional robustness check where you basically throw away half of the sample and say, okay, these are either peers or students, and we're still able to identify these peer value added estimates. So I think in the paper it's maybe a lot clearer, but at this stage we're like super sure that we're not picking up any reflection. Okay. Now let's just assume we would. Then we would not be able to come up with these.
In the interest of time, I would push this discussion to later. Michaela, it's actually kind of you're on next, so your clock is almost ticking. So why don't we switch?
Sure.
Thank you very much.
Thank you very much, Ulf.